Have you ever wondered how spacecrafts navigate through space? It's quite fascinating and less complicated than you might think. Picture this, you're on a road trip, but instead of a road map, you're using the laws of physics and a whole lot of mathematics to guide you. This is the essence of spacecraft navigation. It's the process of planning, guiding, and controlling the movements of a spacecraft from one point in space to another. Spacecraft navigation is crucial to space travel. It's what ensures that our astronauts and rovers don't get lost in the vastness of space. It's the science behind how we've been able to send probes to distant planets, and even beyond our solar system. It's the reason we can predict, with amazing precision, where a spacecraft will be at any given moment on its journey. So, how exactly does this work? It's all about something called trajectories. The trajectory is essentially the path that a spacecraft follows to get from its starting point to its destination. Now, determining this path isn't just a matter of point and shoot. It's a complex process influenced by gravity, the spacecraft's initial speed, and the angle at which it's launched. Let's break it down. Gravity, our cosmic tug-of-war, plays a vital role. It pulls the spacecraft towards the center of the Earth and other celestial bodies, impacting the trajectory. Then, there's the initial speed. Imagine throwing a ball. The faster you throw it, the further it travels, right? The same principle applies to a spacecraft. The faster it's launched, the further it'll go before gravity pulls it back. And finally, the launch angle. Think of it as the difference between tossing a frisbee and launching a rocket. The angle affects how high and how far the spacecraft travels. But here's the kicker. Once a spacecraft is in space, it continues in motion until acted upon by an external force. This is essentially Newton's first law of motion playing out in a cosmic setting. But wait, there's more to it. We also have something called gravity assists. Gravity assists, also known as slingshot maneuvers, are a key component of spacecraft navigation. Imagine a spacecraft approaching a planet. Instead of crashing into it or being sucked into its gravitational pull, the spacecraft uses the planet's gravity as a sort of slingshot. It swings around the planet, gaining speed and changing direction, all without using any fuel. This is the magic of gravity assists. But what about when the spacecraft is already on its way? That's where course corrections come in. Space is not a straight line, and even the best-laid plans can go awry. Course corrections are like the minor steering adjustments you make when driving a car. They are small tweaks to the spacecraft's trajectory made during its journey to ensure it stays on the right path. And there you have it, the basics of spacecraft navigation. But let's summarize what we've learned. So, we've learned quite a bit about spacecraft navigation today. Let's take a moment to recap. We started by unraveling the mysteries of spacecraft navigation, exploring how scientists use complex calculations to chart a course through the cosmos. Then, we delved into the importance of trajectories, the paths that our spacecraft follow, which are meticulously planned and executed to ensure successful missions. Next, we discussed the fascinating concept of gravity assists, a technique that uses the gravitational pull of planets to propel spacecraft further into space, saving fuel and time. We also touched upon the importance of course corrections, small adjustments made during the journey that ensure the spacecraft stays on its intended path. Spacecraft navigation might seem complex, but it's all about understanding the laws of physics and using them to our advantage. So, the next time you look up at the night sky, you'll have a better understanding of how those distant spacecrafts navigate the vast expanse of space. Thanks for watching Universal Facts. Don't forget to like, comment, and subscribe.